Hey folks, as lately I've been even less regular with the videos because I've been studying a bit about Kubernetes. I thought I might as well take advantage of that and make a quick video uh, about running a .NET Core application in Kubernetes. Not a tutorial or anything like that, just a basic like intro. So if anyone doesn't really know what Kubernetes is and is interested in a quick look just to understand why everyone always talks about this, this is it. I will just grab a simple application and put it running with Kubernetes using just some of the features, because there are a lot, and briefly explain some things, but without going into much detail. It's just like a quick overview of some of the interesting things and why everyone always is talking about Kubernetes right now. So it will be kind of like live coding, but not really. And I'll make a lot of use of the Kubernetes documents to copy paste stuff and then adapt to what we need. And as a sample application, we'll use a Hangfire sample I did on a Twitch stream some time ago. It's something really simple. We have an API, which is basically just an endpoint that we send a job and it queues the job. And then we have worker, which just handles the job, which is basically just logging and waiting for 30 seconds just to simulate that it's doing a lot of work. And that's about it. This is the sample application, and it's enough for us to see how to deploy this to Kubernetes and see things working. I already prepared some Docker containers, as we need some containers to run in Kubernetes. One for the API and another for the worker, mostly the same. They are already created. So if I go to the terminal and do docker image ls grep hangfire, you see I already a hangfire sample API and a hangfire sample worker. So we basically will have these two containers plus a container for SQL Server, and we'll see how all of that interacts, and eventually we'll see the application in the browser. So as my head over here in the bottom is not really important, as I'm not streaming, let me just change this to hide it, and let's get started. So let's start. We'll create a YAML. I already created the YAML. I'll call it all.yaml. So we can create our resources for Kubernetes in a bunch of ways. I normally prefer to use the YAML, so we have all the things and put in source control and stuff like that. And we can put them in multiple YAML files, or we can put them in the same YAML file separated by 3 dashes. That's what I'm going to do just to keep it simple. So let's start with the SQL Server Container. So let me go to the docs and let's create a pod. So a pod is the basic thing that we run in Kubernetes. So a pod can run one or more containers. And so let's go over here. And this is an example of a pod. And okay, not a lot. Let me see. Lot of docs. Alternatively, to just create the YAML, we can, in the terminal, we can create a pod. The exam was like 2 weeks ago, so I forgot most things. Just so you are not surprised, when I do k, it's the same as if I did kubectl because I created an alias. So k run, and we want the SQL Server pod, SQL Server container. So yeah. So k run SQL Server image equals this one, and let's say I want dry run equals client and output YAML. Okay, so the dry run means that I don't want to apply this immediately, and the -o is output, so I want to output as YAML. So now I have a basic YAML here. I can copy and put over here. So let me remove some stuff not needed. And I want this. So this is the basic thing. Now for SQL Server Container, if we go to the Docker Hub, SQL Server, this is not really Kubernetes, it's more Docker and stuff. But if we want to run this, we need to provide some parameters like password and stuff like that. So I'll just copy what I have already prepared over here. Okay, so this is being annoying. Don't know why code is annoying me like this, but let's ignore that. So this is a pod where we can put multiple containers. In this case we want one container, so SQL Server, and this is the image, and as environment variables we're going to pass this to accept the EULA. We're passing the password, so basic password, and of course we shouldn't have this in plain text in a file, but this is for demo. And I'm saying that I want to use SQL Server in Developer Edition. Now another thing we do here is we mention the ports that this container will use. And that should be it for the SQL Server pod. Let's see if things are working. Go to the terminal, and if we want to apply that file, we can do k apply file all. Okay, apply file all. So we see that the container is running. We can't do anything with it, but it's running. So we can now get rid of this by doing delete. Now this is cool, but for other containers to be able to access, or better yet, other pods or containers inside other pods to be able to access SQL Server, they will either need to know its IP directly, which is not great, or we can create a service which will, its name will act as a DNS internally to Kubernetes. So when we are in the other containers, we can just reference SQL Server given the name of the service. So let's go back to the docs. and search for service. If we go over here to the service, blah 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 blah, and we have an example. So if we copy this here, go back over here, it's a service. The name of the service, I'll say Sql Server SVC, and the selector is the way for us to tell the service you will forward things to the pods which have this selector. If we see here, the label for this pod is run SQL Server. So we'll grab this and put over here. Now we have to put the same port that we put over here, so it matches. Or better yet, this port is what the clients will use, and we'll put the clients, as this is the default SQL Server, the clients will connect to 1433 and it will just forward to 1433. If we wanted, we could put 1434 and put target port 1433, but it's not useful to be inventing like this. So now back here, apply at all, and now we see we have the pod SQL Server which is running, and we have the service SQL Server SVC, and the other pods will be able to reference it. Let's delete this again, so everything starts at the same time, which is not needed. But now that SQL Server is kind of done, it's not done, we'll be back for some changes. But let's go to the start looking at the API. So now for the API, instead of using pods directly, as you see, I use the pod directly for the for SQL Server, but we can use some things. In this case, we'll use a deployment to be something that's above the pods and controls what's going on. So let me go back over here, no, not here, over here, and we'll see what is a deployment. And also, I didn't mention, but this is not a way to create a database in production, of course, because everything would, when the container goes down, everything goes down. So in production, that's not the way to use databases. And many times we don't really put databases in Kubernetes. Maybe we'll use something like a managed database that the cloud provider provides. But it's also possible to have the databases in Kubernetes, but not the way I did. So this is a deployment, an example. So it's in this case an Nginx deployment, and so it has containers Nginx, and it says it has 3 replicas, which means it will have 3 Nginxes running at the same time. Let's copy this and go back here, and let's adapt. I'll use run instead of app, or better yet, I'll use app because I think most of the examples use this app. And over here, okay, and now we're looking at the deployment. Let's start with 1 replica, match labels, API. This will be our API, and the name will be again API. No, it doesn't need to have the same name. I just did. And the image will be ang fire sample slash 1.0, I think. Let me check. Yeah. Or better yet, comparison API 1.0. That's correct. So this will be the same for the worker. This will change. Okay, and container port 80. So this is mostly should work. Well, let me API deployment. API deployment. So this should work. Emphasis on should. So let's go back to the terminal and let's try to apply. And you can see there's an API deployment over there. Let's do one thing and let's see the logs of the API deployment. Maybe it's all good. Okay, didn't complain. Don't know how it didn't complain, but let's see that. So let's delete this again. And now, like we did for SQL Server, we need a service to expose this so we can access it. So it's again a service. In this case, we'll call it API service. It will match API. It will go to port 80 right now. And in this case, we'll do is use type load balancer. Let's see if the docs mentioned it. They don't mention it. Because this is a deployment. No, this was it. Yeah, this is it. So let's go back to service. Service load balancer. Okay, so the services can have multiple types, like cluster IP. So exposes a service in an IP which is internal to the cluster. Node part, so it will expose the service on the same port on the nodes. Or load balancer, which in this case we'll use what I'm using for Docker Desktop and expose it for us to see outside with a load balancer. But if it was in a cloud environment, it would use something from the cloud provider, for instance Azure or AWS, which would give it, would map it to a load balancer that the provider has available. So in this case we don't need that because I'm doing things in desktop, but that's it. And then it's an external name. So I think this is to map, for instance, to some external. For instance, if we wanted to go to Google but not be tied to google.com, we could create something like inner Google, which would map to google.com or something like that. But in this case, load balancer. So now let's go back to the terminal and apply. Let's get all. It's all running apparently. So let's go to the browser and do localhost dashboard. Okay, get logs. Let's see the API. forget k logs, and now we have exceptions because we created SQL Server, we created the Ankfire API, the API using Ankfire, but we didn't provide the connection string, so it has no idea how to get things working. I thought it would blow up immediately when it started, but apparently only on the first request. So we need to provide the connection string. If we go to the code, currently the connection string is over here in app settings, over here. But this connection string is for when I was running this outside of the container. Now we need to, and outside Kubernetes. So I need to actually provide the connection string correct, which is not localhost. So we have some options, and what we'll use, let's go back here, secrets. So secrets are a way to provide secrets. In this case, we want to provide a connection string, and we can use kubectl create secret, blah blah blah, create generic stuff. And secrets is one of those things that probably we don't want in YAML because we don't want that in source control. But in this case, we'll do it just because it's demo and I prefer to have everything like in source control, so anyone can clone the repo and start things as a demo. If it was production, of course, we don't want this. So let's copy this. Go back to the code. I'll put this closer to SQL Server so it can be here. Secret here. Let's call it SQL Server Secrets. We'll probably use more than one. I'll change this data to string data, so we don't need to do this encoding stuff. And let's start with a connection string. We'll use more things later, but right now, connection string. And I'll just copy this from another place. I have this already done. And that's it. So we'll call the database Ankfire sample, SQL Server Service, if I'm not mistaken. SQL Server Service, yeah. And user ID, SA, and password, the same password I put up there. So now we have a secret. And now we need to map it to the API. Let's go back to the docs. Where is that? Okay, over here. And if we want to use the docs, yeah, create secrets, I know. I want the using secrets. We can mount the secret as a volume, or we can mount them as environment variables. Environment variables. So that's what we want over here. So let's get back to over to the API deployment, to the container, and we want this. So the name will be connection string, and we want to go to SQL Server Secrets connection string. So these two didn't need to match, they just matched because I wanted, but we could call this whatever, as long as it matched what is up there in the SQL Server's secrets. And now this will be mapped as an environment variable, and as you might be aware, ASP.NET Core automatically puts any environment variable, so overrides what comes from the app settings. So now if you run this, it will not work, but the reason will be different. So let's clear, okay, apply. So okay, get all. We see everything's running, so we can go back and grab this pod deployment stuff. You see the other pod as a simple name because we created the other pod by itself. But in this case, because it's using a deployment and we can have multiple pods from a deployment, it has this weird stuff generated. We'll see more about that later. So let's, okay, logs this, let's put -f to follow. Okay. Okay, so now the error is different because the database now, it was able to connect to SQL Server, but not to Hangfire database, because the database doesn't exist and Hangfire doesn't create it automatically. So we'll need to create a database for it to use. And this is an interesting mission for something in Kubernetes called Init Containers. So Init Containers are containers that run before the normal containers in a pod, which can prepare stuff. So what we'll do is create an init container that creates the database or ensures the database is created. Before that, we could do that inside our Hangfire application, but and I don't think there's anything wrong with that, but with all that separation of concerns and all of that, it's interesting to do it this way. So the application is the application, assumes everything is prepared for it, and also probably in real production we don't want an application creating the databases automatically. Probably DevOps or something like that will create the database before. So this kind of simulates this, but in a demo environment. So because I don't know, all this is weirder, not the init container stuff, but there is this thing. I think there's some tools. There's a container with tools for SQL Server, which is called MS SQL Tools. If we try to find it, no, okay. And this has command line tools to access the SQL Server database. So we'll create a container, an init container based on this, to check, to ensure that the database is created. So let's go back to over here and create some init containers. So init containers, we'll call name create database, image will be that one. Then what we'll use a command. So it will basically tell this container, run this command. And I'll copy paste this because it's a bunch of stuff. Let's see. So this is just to execute a shell script that comes next, and then we go to SQL Tools, SQL Server Service with user SA, password that we'll need. So it's an environment variable. And then I'm connecting to master, check if the Hangfire database exists. If it doesn't exist, create the database. So by using the init container, the other containers, these ones, will only start when the init containers are finished. Now we need this password. How can we do it? Let's go back over here. And besides the connection string, let's just say password. And we'll copy this over here. And now we can map it the same way we did for this one. So copy this. I'm missing the inf. And it should be, no, it's correct. Instead of this should be called password and password. And okay, I think it should work now. Back to the terminal. Okay, get all. Okay, logs. Okay, logs for this one. Seems to be up, seems to have no errors, so let's go back here and we have Hangfire working. So servers, there are no active servers because we didn't create the workers, but Hangfire itself is working. Now this is really not needed here, but since we can do this in the context of the demo, let's do one thing. That is, there is one thing called, let's go back here, Liveness Probes. Yeah, so we can configure this in our pods so that the service knows when other containers are ready or not. Not only the service, but one of the interested parties, it's the service, so it can forward or not new containers in there, requests to that container. So let's see, we can have Liveness Probe in multiple types. So get, HTTP get, yeah, that's what we want. So we'll put Liveness Probe. Let's copy all of this and go back over here and let's add elf port 80, no need for this, and we'll say initial delay seconds, let's say 1. It will wait 1 second before trying, and then every 5 seconds we'll see if it's already up. Let's put 1 second just to be faster. And we can create something that's basically the same, but is a Readiness Probe. I think every thing configured is basically the same. So the difference is Readiness Probe is to check if the container is ready to receive traffic, while the Liveness Probe is after it is ready, is it still able to do that? So if I didn't put this in the wrong place, let me just check. Yep. Let's try again. Get all. So it's, if you see, it takes a bit, it's init, because the init container is running and creating stuff. And now things are working. let's do one thing. Okay, not the logs this time. Okay, describe this pod. So if we see over here initialized, it mentions the probes. Seems to all be working. Now let's do another thing. Let's go back to over here and let's point to 81. Let's apply again. Better yet, let's delete. So we see things. But as you see, what was happening is because we did changes on the container, what Kubernetes does is start a new one, try to start a new pod, and when it's done, deletes the other one. So it's a rolling update. Not going to touch that subject, but so let's apply, and now okay, get all. So it's the init container. Now it seems to be taking longer. So let's do k describe. So it's failing the readiness probe. So now we see there's a crash loop back off because, and it's restarting because it's not able to reach it. And even though it's working, if the readiness and liveness probes are reporting that it's not good, then Kubernetes tries to restart the pod to try to have things working as they should. So if we go back to over here, back to 80, and apply again, okay, get all, it's creating a new pod. Wrong. It's creating a new pod, initializing, running, so the old one is terminating. And now we have things working, and we can go back to over here, and this is working, and we can go to localhost health, and it's healthy. So all good. Now the last thing that's missing is the worker, because right now if we send some requests, let me open up the app, Insomnia, so let me put it back here, it is huge. Let's create what happened. I don't think it's liking this scaling. So new request. It is a post, I think. Let's just check the code. Startup. So a post to queue and some ID, which is irrelevant, but let's pretend it's not. A post to HTTP localhost job ID X. Okay. So now if we go over here, there are queue jobs, but because we haven't started any worker, they're just there. So we need to start the workers. So let's go back to the YAML. And we'll basically copy this just so it's quicker. Copy this till here. This will be again a deployment, in this case a worker deployment, worker. We can let the same init container, as it has the same dependencies. Over it will be worker, we don't need to expose any ports. We could, but we don't need because the worker, I think I didn't implement any API in there. Or even if I did, let me check just in case. Oh, in fact, there is the dashboard is there, and there's an hello world. So we could use the Liveness Probe, but no need. So worker stuff. Yeah, worker. And use the connection string again, stuff like that. So let's go back over here. We don't need to start to delete the other things. We can just go, so okay, get all. And now we have the worker deployment and it's running immediately. No need, the init probably was faster because the database is created. As we don't want to access the worker, we don't need to create a service. The worker is just there running in the background. So let's go back to the browser. And it's processing. So immediately the worker started, connected to the database, and started working on things, and they are succeeded. All good. No jobs there. Now, as you noticed at the beginning, I showed that the handle job is basically just waiting 30 seconds. So that means that if we enqueue a lot of jobs, it will the queue will start to grow. So let's see that in action. I'll go back to Insomnia, and I think there's an option here that I discovered a day. Repeat on interval, and I want like every half a second. So now it's doing requests. And we go over here. It's enqueuing. Fire dashboard, should be things happening or not. No, not really. Okay, stuff in there, whatever. But if we go over here to the jobs, we see there are 20 processing, which I think is the default. Angfire processes 20 jobs in parallel per node. And the jobs keep getting enqueued, so the queue will start growing. If we go to the servers, we have a sample worker, and the jobs are growing because Insomnia keeps going. You can wait a bit, and this will grow and stuff like that. But then it's where we can go over here. Let's go back over here. And there's these replicas. So let's put 2 in here. And let's go back to the terminal and apply. So if we do get all, now you see there are 2 pods for the worker. And we just changed 1 to 2, and Kubernetes applied the configuration. One is older, 3 minutes, the others 3 seconds. Now if we go to the dashboard, now there are 40 jobs working in parallel, and there are 2 servers, same name but different GUIDs, I say. Yeah, look at the jobs. So now it's able to keep up with Insomnia creating the jobs. Is there a way to make this faster? Repeat on interval. 0.25? No? Okay. So this should start growing, I think. Or not. Okay, now it's growing. So 40 processing, the queue growing a bit, not a lot, maybe not fast enough. No retries because there are no errors, servers, jobs, stuff like that. So if we want to adapt things, we could either over here change the replicas, or in the terminal we can case scale deployment, worker deployment, replicas 1. So if we do get all now, one pod is terminating, and if we go back to Hangfire, we have one server, the other went down. This job was aborted, apparently. It was because the pod went down. It will be retried eventually. So, but this is Hangfire stuff, not really Kubernetes, but interesting to see. And if we see that this is, we need more, we can 3 replicas. And now, eventually we'll have 3 servers. And processing 60 at the same time, and the queue, and all of that. And I guess this is enough for this brief intro that's probably long, but hope it's useful for someone who has no idea what is this Kubernetes, how this relates to the applications we develop every day. So I hope this is like some little enlightenment, and if you're continue to be interested, you'll look for more resources that you can learn a lot more. But this is just like to poke your brain and say, okay, this exists and this is why it matters, even if not everyone should worry about this. But if you're a backend developer, it's maybe interesting, not needed, but interesting to know what's going on. And okay, that's all. Hope you enjoyed it, and hope to see you in the next one. See yas!